Hi there, I'm Dave Litton and a very warm welcome to my brand new Microsoft Project 2010 Primer. Now you may be aware that this is the current and very latest version of Microsoft Project, and you also may be aware that I've developed a reputation for taking complex information and breaking it down into easy bite-sized chunks. Well, you'll be pleased to know that that's exactly what I've done here. Now, Microsoft Project is nothing more or less than a very powerful and successful tool that helps the project manager to plan, monitor and control their projects. It will never replace project managers, thank goodness, and it needs to be used with best practice methodologies, as you might expect. Now, I've been managing projects in the IT industry for over 25 years now, and I first started using Microsoft Project in the late 80s. It was around version 1 or 2 if memory serves. And what's interesting is that Microsoft Project hasn't changed that much in terms of its main objectives. And that is to take task and resource information input by the project manager and to present it in a logical series of views. And although this latest incarnation is considerably improved from those early versions that I started on back in the 80s, it still retains the basic characteristics of a database where you, the human operator, puts information into it. Much like this. Basically, it's a project database where it takes task and resource information and presents it in a series of ways to help you, the human operator. Like all things, of garbage in equals garbage out. So it starts with you, the human operator, if you will, putting data in to do with tasks and resources, and Microsoft Project carrying out a multitude of complex calculations very quickly and behind the scenes to give you information so that you, the human operator, can make informed choices about what to do next. It takes your tasks along with the resource assignments and presents them in a schedule or timeline, if you will. It gives you different views with supporting sheets and so on. You'll be familiar, I expect, with the Gantt chart view, which, just like back in the late 80s, is still the default view, and for very good reasons, as I'm sure you'll already know, and if you don't, I'll certainly show you why it's so valuable in the coming modules. Let's just talk about what this primer actually entails. Much like previous primers, which you may have seen and used, this consists of a set of video modules, this being the first. Supporting each module, I've put all this information in one workbook, and for each module, which is based on either slides in this case, or when we start looking at Microsoft Project itself, live screenshots of me using Microsoft Project, I've made it so that you can learn in easy bite-sized chunks, and every single diagram will be included in the workbook. My other main objective was not just merely to teach you all the functions of Microsoft Project, but to actually use it as you might in real world. So my main objective in designing this primer is to give you real world experience, and to that end, accompanying this, you'll have a series of project files which you'll take from the very start of a project right the way through to printing and reporting and communicating. Just like the advantages of my previous primers, you'll be able to use this at a time when it suits you. You may want to watch some of the videos many times, others you may only need to skim through them. In each case, the exercises are there to help you build an understanding, and how much time and effort you put into that will be down to you. The promise I will make to you is that if you go through and watch, take notes, listen and learn to all of these modules, at the end of it, you'll be able to take that information and use Microsoft Project immediately for your real-world projects. The other thing I wanted to ensure is that we all start this from a level playing field. And to this end, this first module will not be about Microsoft Project per se, but to make sure that you understand some of the basics of project management. It may well be that you're already an experienced project manager. However, I think you'll still get some benefit from skimming through, at the very least, this first module. It also lays down some ground rules as to how Project thinks. So for that reason alone, I think you'll find this first module useful. In Module 2, we'll actually start work on Microsoft Project itself. Most of the modules will start with a few slides, much like this, where I want to set the scene before introducing those aspects using Microsoft Project. I've deliberately designed this primer so that you can use it at a time and place that suits you. Like all videos, you can pause, rewind, watch as many times as you wish. Or if you're feeling fairly confident, skim through one time only. Accompanying this are useful exercises based on a simple example of a real-world project to make getting to grips with Microsoft Project easy step by step and something that you can apply immediately in your real world. So let's make a start then, looking first of all at the basics, if you will, the world of projects themselves. Starting with the characteristics of a project. Every project is unique in that it has never happened before. You may have done similar projects, but in some way, this particular project, your latest, will maybe have different resources, different products, different amounts of risk, the environment of the project. All of these, or some of them, will make your particular project unique. Projects are temporary in nature because, of course, they have a beginning, a start date, and an ending date. And it's against these that you'll be producing your plan. Projects are completed when the project goals or the outcome are achieved. Similarly, they should be stopped or changed in some way when and if they are no longer viable. The word viable here refers to the business case. And a business case is basically a balance of the costs, risks and time on one side against the benefits being achieved on the other. And if for whatever reason the business case is no longer viable, then the project should be stopped to continue wasting any more resource or effort on something which has no longer any business benefit. Or it might be they need to be changed in some way, perhaps rescoped, so that the business case would be viable if you now continued with the project in a changed way. Successful projects meet the expectations of its stakeholders. You might see these stakeholders as senior management, customers or users, or all of those. Moving on to the nature of a project. A project is normally cross-functional in that it draws upon resources from various parts of the organization typically, and maybe even external organizations. Because each project is unique, it therefore has some amount of uncertainty or risk, if you will. Projects are constrained by whatever, time, cost and so on, as we'll see shortly. And a project must meet certain objectives for it to be successful. As I've already said, a project has a start and a finish, and it's therefore temporary. Now, Microsoft Project is nothing more than a tool. And you must understand that the project plan is a document. It's not just a Gantt chart or a diagram or a bar chart. And this document contains much written information as well as illustrative data taken from Microsoft Project. So a project will consist of a list of tasks, often called a schedule, represented here, as I've shown, as a Gantt chart bar, each task having a start and a finish, a start and a finish, and so on. However, tasks themselves won't get the job done. What you'll actually need is sets of resources. Now, for the most part, these will be human, individuals with the right knowledge, skills and experience in order to carry out the work that needs to be taken place on each of the tasks. But resources may be non-human as well. For example, facilities, materials, equipment, tools and so on. Therefore, a realistic project must recognize what resources are necessary and applied to each task as appropriate. Now, when first planning exactly what these tasks are, it's easy to forget that since projects have uncertainty because they are unique, they therefore have risks. And these risks need to be managed by the project manager. Now, how you do that, of course, is you develop a set of responses, either things you do up front to reduce the risk in the first place in terms of its probability and or impact, but also responses that should the risk occur, that you put some action plan in place. These are often called contingency plans or fallback plans. The point being here is that these responses are nothing more or less than tasks with resources on them. So it's not just the technical tasks and the resources to carry those out, it's also those necessary to manage risks. Now, a risk could be defined simply as something which has yet to happen, and it may or may not happen at some point in the future. And if it does, it will have an impact in some form on your project. Whereas an issue is something which has already happened and needs to be managed. I've lumped together here issues and changes. There is a school of thought that takes the view that a change is simply a form of issue. If someone says we now want something different for whatever reason, you need to look at that and to find out what the impact is. So therefore you could see it's a type of issue. An issue might just be a standard problem or a concern, but it still needs to be managed. So guess what? It means you'll end up having tasks with resources on them to help manage such issues and changes. And probably the most important aspect of project management is that of communication. Remember that communication is what information is important, who needs to get and to give that information, when it should be given or obtained, who needs to give it or receive it, and the form or manner or channel, if you will, of how that communication needs to occur. Again, how communication is to be carried out, much like issues and risks and changes, will be built in within the project plan. But communication, of course, means tasks and resources, again, so that your project plan will consist within it of a Gantt chart with tasks and resources, not just for the specialist or technical aspects, but also for these as well. I bring this to your attention at this point to remind you that although that in the simple exercises I shall be using to help build your knowledge of Microsoft Project, that in your real-world projects you would want to include such tasks and resources in order to make it a realistic and achievable project plan. Continuing with the definition of a project, projects bring about change, and therefore project management is recognised as the most efficient way of managing such changes. We already know that projects are unique, they're transient endeavours, and they're undertaken to achieve some form of desired outcome, the change which we're talking about here. So at its simplest, a project consists of activities being done to meet specific change objectives. Now, the project manager must handle, juggle and prioritise many factors in order to deliver the project. And these, of course, must be agreed by senior management, your sponsor, customers, users, or what have you. And you've probably heard of the TCQ aspects of a project, standing for time, cost and quality. It's often called the Holy Triangle, although there's nothing the least religious about this, but it's certainly key, in that every project within constraints must be delivered against some time frame, against some budget constraints, and to meet the quality requirements that the customer expects, normally manifested in the form of requirements. But scope is interesting because it's something which means what's included and what is not included. The boundary, if you like, of the project represents its scope. And if you don't carry out scoping, it's highly likely your project will either miss certain products out, or worse, do too much and therefore increase time and cost when it wasn't really necessary. So this has been developed and evolved, and the latest best practice suggests in fact that a project would want to consist of not just time, cost and quality, but also scope, as I've inferred here, and risk. For example, how much risk is too much risk? How much risk tolerance or appetite do management, sponsor, or whoever have for a particular project? And therefore that is a constraint that the project manager has to manage, to make sure that the risk is managed and contained such that it becomes acceptable to your senior management, your customers and your users. So what's the purpose of actually carrying out projects? After all, you're tying a load of resources up for a time, you're spending money on it. For what reason and purpose? Well, the answer is that projects bring about change, and what we're looking at as a desired outcome, normally expressed in terms of a capability. Imagine a project to put in place a new help desk for your organisation. You need the capability of perhaps responding in a more efficient and effective manner to your customers. Thereby, what's driving this are the benefits. and the benefits of any project are laid out within a business case. Again, I mention these points because you won't find me explicitly talking about capability and benefits in helping you to understand Microsoft Project. But ultimately, everything you do is there to realize business benefits. So what is it that makes up a project? Let's summarize where we've come to. We have the project manager, of course. We have a set of goals or objectives that the project needs to meet in order for it to be seen as successful. A project produces deliverables or products, sometimes called. A deliverable is anything that the project delivers. A product is anything that the project produces. Therefore, these are both the same. And I want to clarify the difference between a task and a product or deliverable. A task is normally written as a noun and a verb. Dig hole, make breakfast, write a report. Whereas a deliverable is a noun or outcome. New help desk, as an example. So be clear, although we're going to talk about tasks and resources for the most part of the remainder of this primer, don't forget that what you're doing is actually producing products or deliverables. And I'll show you how Microsoft Project would illustrate those when we look at tasks in a later module. We know about the Gantt chart as a standard view showing a load of different tasks along a time frame, and each task showing the start and finish and how each relates in terms of the time frame to the other tasks. These must be laid out in a logical sequence. We know that projects consume resources. I've suggested people, equipment, material, facilities, and so on. And of course, budget. You could argue that that's a resource, but it's also the budget and what the project will cost. And if this is a commercial project where you're producing some end product that you will sell to customers, then you need to make sure that the costs of the project are such that you can make a reasonable profit. And again, the business case will show that that should be viable, and therefore the project plan is realistic and achievable and viable. Let's talk about the project manager. Again, you'll need soft skills, if you will, as well as the ability to use tools like Microsoft Project. But within a project, the project manager needs to understand the needs of the stakeholders. What does each require? The project manager needs to create the plan, showing exactly what work needs to be done. The project manager needs to acquire, procure, build and motivate the team to make sure that the work is carried out in an effective and efficient manner. The project manager needs to understand what work is to be done, when it's to be done, who will do it, and what standards against which the work is to be done. I talked briefly about products. You'd want to know what the quality criteria for each would be. The project manager coordinates the work of the various people within the team. These may include the specialist team, creating the specialist or technical products, as well as working with other stakeholders within the project, including customers and users, as an example. The project manager needs to monitor that the work is going according to the plan that's been created, and as and when necessary, taking action, corrective action if you will, to make sure that the project keeps on track against the plan. Changes will come at you almost inevitably, and therefore the project manager is responsible for managing such change. The project, of course, must meet its objectives and deliver successful results. What we mean by this is that the end products have the full potential to realize the benefits laid down within the business case. So projects bring about change, and project management is recognized as the most efficient way of managing such change. It's worth just saying here, of course, you can bring about change by other methods other than by projects, like a personal assignment, for an example, but projects are seen as being the most efficient way of doing this. Management, therefore, as a broad definition, is the process of leading, planning, organizing and controlling the resources of your organization to achieve stated goals as productively as possible. Project management, therefore, is the process by which projects are defined, planned, monitored, controlled and delivered such that the agreed benefits are realized. And Microsoft Project is a powerful tool that helps you take your definition, and to create it into a realistic and achievable plan, and to give you information such that you can monitor it and control it by taking corrective action where necessary. Now, the project management plan is a document, as I've been at pains to demonstrate already, and here are some typical contents of a project management plan. You may be interested to know that this is drawn directly from the Project Management Institute's project management body of knowledge, and you'll see there are various aspects to any project management plan. I won't go through these, it's not necessary, as this is simply an overview video, but you can see here that the human resource plan shows you the types of skills and knowledge experience you need and when you need them. Change management plan shows how you will manage changes throughout the project, and so on. The ones that probably are particularly important is using a term called baseline. Now, a baseline is a configuration management term, and it means the agreed management reference point against which any project will need to be monitored, managed and controlled. However, it's not just a single collection of data. For example, you have a cost performance baseline showing what costs will be incurred when. You have a schedule baseline which shows when certain tasks or activities will be undertaken. You have a scope baseline agreeing exactly what's included and what isn't. So the project management plan is a single formal document that defines how the project is to be managed, executed and controlled. And you can see that Microsoft Project would play some part in this, in that it would help produce these three baselines for sure, but also it would include tasks that carry out some of these other aspects. For example, as I've already touched on in a previous slide, how you intend to communicate, who you need to communicate to, and so on and so forth. The project management plan is progressively elaborated, meaning it's created in the first case and approved by management, but then continues to be refined and revised and updated in a continuous manner. You can see here as well how Microsoft Project will help this refining, revision and updating as a supporting tool in making sure that the project management plan remains viable and achievable. In short, the project management plan specifies the who, what, when, where and how of any project. Now I want to touch on project scheduling, and this is important because I want you to start considering what is called the dependencies of each of the tasks. Now, Microsoft Project is employed to formulate what is called a network diagram. I've shown here actually the Gantt chart. We'll see that a network diagram, sometimes called a PERT chart, is another view. But let's use the Gantt chart since it's the best way to put across the point I want to make here. We've already said that this shows the time frame, the overall plan duration if you will, and it shows when each activity or task is due to start and finish. In this very much simplified view here, I want to remind you we're talking about dependencies. So we can see that one task finishes, and in this case, two other tasks start. We'll see how Microsoft Project automatically calculates the so-called critical path of any set of activities or tasks linked together. It will even automatically show critical tasks as red and non-critical tasks as blue. But again, what I want to focus here is on the dependency links between each task. And before we get into more detail on that, let's remind ourselves that scheduling is the process used to determine the overall plan duration, when certain activities or tasks or events are planned to happen. This will include identification of activities and their logical dependencies, and the estimation of activity durations, taking into account the requirements required and the availability of resources. Now this is an important point, you see. It's all very well saying you need these tasks done here, in this sequence, in this timing, but you need resources to carry out the work. And depending on the availability of such resources, you may find you need to move such tasks in time to allow for the fact that when such resources are actually available. The other element which will result in a realistic schedule is, of course, the durations derived from the estimation of the work effort within each task. We'll touch on this in later modules, but for now, just consider the fact that if someone needs to carry out 40 hours work to create some product within a task, then the duration of the task will be based entirely on that estimation being as close and correct and accurate as is possible. So let's now look at the different logical dependencies that you will come across within Microsoft Projects and you may need to apply in your real-world projects. Let's talk about external dependencies to start with. So forget about the logical dependencies between tasks within a project. You may find, and these are just examples, that a new software release which is needed at some point within your project, the planned date for when that release occurs could be seen as an external constraint. Therefore, certain of the tasks are dependent on this date being met. Let's imagine you're doing something in the building or construction industry type of project. Getting planning permission. You can't start building until you've got that. That again would be seen as an external dependency or constraint. Or that an installation manual is being created by a different company or organization, and that this will need to be in place before you can carry out further tasks within your project. These are seen as external type of dependencies or constraints. Now the first type of dependency I want to discuss is called a discretionary dependency. If you're making a salad to accompany chicken, I'm here showing that you want to prepare the chicken first and then the salad. Well, why? You might decide to prepare them both at the same time, particularly if there were two of you. Or you might want to prepare the salad, put it in the fridge and leave it there. Maybe it needs to marinate, and then prepare the chicken and then add that to the salad later. So a discretionary dependency is one where you choose, for whatever reasons, I'll do this first and that second. The other type of dependency is called a mandatory dependency. For example, you need to set up the barbecue first before you can cook the burger. So you'll find some of them are logically mandatory. The other concept I want to put across is called a lag, and we'll see these in Microsoft Project. Imagine you're laying a foundation, a concrete or cement foundation, and it needs to be hardened before you can erect a statue on it. Therefore, you have to wait 24 hours for the concrete to cure, if you will. This is called a lag. Instead of saying directly this is finished, this can start, you say directly this is finished, you've got to wait a certain lag period before you can do the next task. The exact opposite of a lag is called a lead. Let's take design and code software for example, and then when you've designed and coded it, you can start testing it. Well, it may well be that you could start testing some of the software before the coding is entirely complete. So a lead here, and I've given an example of -3 days, means that you could start testing some of the software before all of it is designed or coded. Perhaps coming back to an example of a refurbishment type of project. Just because painting and decorating is not fully complete, you could have the electrician installing some new light fittings while that's going on. Now, there's something else you need to be aware of, and that is that I've talked about a task finishing before a second one can start. In this case, I've just shown a lag of 5 weeks. Perhaps you need to design and then use it for 5 weeks before you start building it, for whatever reason. But the point I want to make here is it's called a finish to start. The predecessor must finish before the successor task can start. And for that reason, it's called an FS or finish to start. But you'll find that there are also other combinations, like start to finish, or start to start, or finish to finish. And you can combine any of these along with leads and lags. I'm going to show you a few examples here. So what this is simply saying, a finish to start with a 5-week lag, that build will start 5 weeks after design is finished. Another example, design and build are both connected start to start. However, I've put a 4-week lag. What this means is that build will start 4 weeks after design has started. Exactly as it says here. Now, a concept I want to put across to you, because quite naturally we think about predecessor tasks and successor tasks as one before the other, but I want you to start seeing them as merely the linkages. We've, by setting up this, said quite clearly that we will start building 4 weeks after design has started. Another example, again using design and build. This time they're connected finish to finish, and again, just to make it more interesting, I've put a 15-week lag in here. What this says is that build will finish 15 weeks after design has finished. Can you see? The dependency relates to the finish of design to the finish of build, and it's been connected finish to finish. All of these options you can do within Microsoft Project. One more for luck. This is start to finish. Notice the dependency is between the start of design and the finish of build. This says quite clearly that build will finish 40 weeks after design has started. Now, it may not be absolutely clear to you why you'd want to have all these combinations for now, but we'll discuss this further in remaining modules. Let's show a practical example that I've invented. Here we're going to, let's imagine your local authority, your local council, whatever, is going to erect a statue in your village square. They're going to order the statue, dig the foundations, erect the statue, unveil the statue with the mayor, and take photographs and put it in your local paper. Imagine that as a simple little example project, if you will. So tasks 1 and 2 have a 1-day lead. That is, you can start to dig the foundations before the statue arrives. Tasks 2 and 3, dig foundations and erect the statue, have a 1-day lag. That is, the statue cannot be erected until the foundations has dried, just like the example I gave you in the previous slide. However, task 4, unveil the statue, has a start no earlier than constraint. The reason is that the mayor cannot unveil the statue any earlier than day 23. So another type of constraint that you'll better learn that you can do with Microsoft Project, you can anchor certain tasks to certain key dates. And finally, that task 5, you'll notice, has a start-to-start relationship with task 4. The reason that's been chosen is because obviously the photographer and the mayor must be there at the same time to take the picture. So there's just a very simple example of how you might apply some of these ideas. Let's move on to look at what's called often a precedence diagram or a network diagram. This represents each task, instead of a bar against a Gantt chart or bar chart, as a box where you'd name each task. I've merely called them letters of the alphabet here, and showing the duration of each task. This shows the linkages, so it shows that task A must be finished first before we can start task B, C and D, and that D must be finished before task I can be started, and so on. Let's imagine this is the start of your project and this is the end of the project, shown as a network diagram. These, the activities themselves, or tasks as Microsoft Project calls them, are called nodes, and of course the dependencies are shown by arrow linkages. I'm showing you a simple network diagram here with a few numbers painted in. The method of layout for each of these nodes is that here is the start date of the project or time, and here is its finish date or time. Here is its duration. Let's assume this is in days. So it starts on day 0, time 0 if you will, and finishes at the end of the second day. And that's shown for each of these nodes or tasks. Now, to put this concept across to you, I'd like to use the example of perhaps you and I and a few of our friends meeting after work for a drink in a local bar. Let's imagine that I'll be there promptly at 5 o'clock since I'm paying after you've finished working, and that you can come 10 minutes later because you've got to meet someone first before you can come in and have a drink with me. And let's imagine some of the other friends that we're also inviting, again, have got other commitments and will come in at various times. You'd agree that the earliest possible time that we can get together, raise our glasses and say cheers, will be when the very last person enters the bar. And therefore the very last person in project talk would be on the longest path. And the person on the longest path would therefore be the critical path, and by that we mean it is time critical. So what our intent here is to link all the tasks together, showing their logical dependencies, and ask ourselves when's the earliest finish date. And the earliest finish date in this case will be the longest path. and I've shown this here with a red outline with yellow highlights. But there are many paths to get from start to finish. There's this one, there's this one, and there's this one. How do we know this is the longest path? Well, we could simply add them up, and that's pretty much what we'll do. But if these are non-critical tasks, and trust me for the moment, they are, how do we know they're non-critical? And what do we actually mean by non-critical? So let me very quickly take you through this. What we do is, and what Microsoft Project does for you in a matter of milliseconds, is it does a forward pass calculation, comes back and does a backward pass. And here's what it does. Starting at time 0, it adds the duration of the task and puts it here as the finish time. Now this is the earliest finish time. We then take this number here, and since these must all start directly this is finished, we can take that number 2 and put it here, here and here. And now in a similar way add the duration of each task to get the finish time, in this case the earliest finish. 2 plus 3 gives us 5, 2 plus 2 gives us 4, 2 plus 7 gives us 9. Now in the case of these two up here, going forward, we've got one at 5 and one at 4, and the rule is you always take the longest duration, or rather the latest date. In this case it's 5, so it's 5 that's transferred to here, not the 4. Again, we add on the duration, giving us 9. Now if you followed these through, 2 plus 7 gives you 9, carry 9 on to the next one, 9 plus 5 gives you 14. We've now got 2 feeding into 1. Again, we take the longest or latest date, in this case 14. We put 14 here, add 6, giving us 20. This becomes the project end date. So in carrying out the forward pass calculations, we will immediately know the finish date of the project. Now we need to do the backward pass calculation. So we take that 20, feed it back in here, and this time we subtract the durations. 20 minus 6 gives you 14. Now ignoring arrows because we're working back, we can see that this task feeds into or looks back into 2 tasks. The rule when going backwards, when you're taking one task into several, is merely to take that number and place it here and here. Again, we can now subtract the duration in each case. 14 minus 4 gives you 10. 14 minus 5 gives you 9. Take back the 9. 9 minus 7 gives you 2. Hold that thought. And by the way, these are showing late finishes and late starts in each case. Come back to this one, going backwards again, much like here. Looking backwards, we're seeing this going into 2 tasks. So we merely take this, 10, and put it bottom right. And now subtracting, 10 minus 3 is 7, 10 minus 2 gives you 8. Which one do we feed back here? Because in this case, it's not 1 feeding into several, it's several feeding back into 1. Well, in the backward pass, you take the lowest number, 2, 8 or 7. It's got to be the 2, of course. So we put the 2 in here, subtract its duration, giving us 0. So that's all the calculations done. What now gives us the critical path is we look for the difference between either the front pair of numbers or the back pair of numbers. Whenever they're the same, it's a critical task, meaning time critical. So you can see that clearly shows these as being critical tasks. Either by just looking at the back pair or the front pair, we immediately see these are critical tasks. In short, it means that these tasks alone dictate the finish time. If any one or combination of these tasks took longer, then this would be later. If any one or combination of these took shorter times, then this would come in earlier. Up to a point, of course, because we now need to discuss the non-critical tasks, where you have a difference either between the last pair or the front pair. Because you added or subtracted in both cases, the difference will always be the same. The difference between 14 and 9 is 5. The difference between 10 and 5 is 5. This is called the slack, sometimes called float, and that goes in this little box here. So you can see that these, by definition, 0 slack is what you get on critical tasks, because there's 0 difference. And it's this which is called slack time. What this means here, taking this fitting windows, is that this task could start and hence finish up to 5 days later than the plan, and still the project would finish on time. Put another way, it could take still 4 days in duration and start on at the latest on day 10, or it could take 4 plus 5, 9 days duration, and still the project would come in on time. So why is this helpful? Because it allows the project manager to ensure that the most experienced people are put on critical tasks. It allows the project manager to focus and review and monitor critical tasks more regularly, and the reverse for non-critical tasks. We could put people who are still learning their trade, knowing if they took a little longer, it wouldn't cause the end date of the project to be delayed. So that very quickly and rather simply is talking about critical path. We'll see how Project automatically does all of these calculations, and even will show you critical tasks as red and non-critical tasks as blue. Let's now just touch on resource management. I've taken a very simple example here of two tasks, task A and task B. And let's imagine that part of them share the same time frame. On this one we've got Tom, Dick and Harry, and on this one Tom and Dick. Well, Harry's okay, because he can work full time on this, but Tom and Dick at this period of time are being asked to do two tasks full time. Therefore, Harry's okay, but Tom and Dick are over allocated. Now, if Tom and Dick were only working half time on this and half time on that, then it would be okay, wouldn't it? But let's assume they're both full time, hence this would be a problem. Now, in a Gantt chart, as a network diagram, you can't see explicitly what the resource information is, and for that reason Microsoft Project gives you different views and different sheets and tables that show you exactly what the resource situation is, including, by the way, histograms and graphs. So resource management is a process that identifies and assigns appropriate resources to activities such that the project is undertaking using appropriate levels of resources and within an acceptable duration. We'll find, therefore, that when it comes to generating the tasks and their dependencies, but then considering the resources, that will have an impact. Now, resources can be human or non-human. Some are replenishable, some are reusable. People, of course, aren't. You can use them on several different tasks, but materials are normally consumed and used within carrying out a task. Equipment is used and then put back into the equipment storage, wherever that might be, when they're finished. Using facilities like meeting rooms or presentation suites or training rooms as an example. Money is a resource. Accommodation, perhaps for staff that are working away off-site when carrying out some activities. Use of certain machinery, provision of services, the procurement of goods and the use of tools. All of these are examples of resources that need to be applied. If a training facility is being used on task A, it can't be used on task B at the same time. So whether it's human or non-human, we need to consider resource management. Also, of course, in your organisation, you're probably not the only project manager and yours is not the only project. So we now need to consider resource constraints. If you've got a resource manager, you may find that they're saying, for example, they've only got 2 engineers when you're asking for 3, like Tom, Dick and Harry. Take it or leave it. Unless you or your management are prepared to go outside and to hire in part-time staff or to take on contractors, then you'd have to reschedule your project to take into consideration that you can only have, for example, Tom and Dick and not Harry. So you'll find that when considering resources, you may need to reschedule. Now here's a view of a Gantt chart after something called leveling. We'll learn about that more later. These are shown as simple tasks. I haven't shown the linkages. We can see here these are the critical tasks and the blue ones are non-critical. But that's not my point here. Hopefully you can see here, starting at week 1, week 2, week 3 and week 4 and so on. Let's imagine for this first task, task A, that we need 4 people full time on it, shown here. When it comes to this point in time, both B and C need to be worked on. Let's assume in this case you have 2 people full time on each. Again, you'll have 4 people for each week, 4 person weeks if you will, and so on and so forth. If we now take these and look at the cumulative total, at the end of week 1 we'll have used 4 person weeks of effort. At the end of week 2, having used another 4, we've now cumulatively used 8 person weeks, and so on and so forth. So what this shows at the end of the project here, you need 106 person weeks of effort. I'm just assuming that every person has the same set of skills and that you could use them for any particular task. So this shows how many resources are on each task and will allow you to determine in which time period resources are needed and their cumulative total. That cumulative total is important, as we'll show shortly. So what we could do is represent that instead of a set of numbers, but as a histogram. Here again, showing in week 1 you need 4 individuals, and so on and so forth. In week 8 you need 2 individuals, and so on and so forth. Here I'm merely showing the height of each bar to represent the number of people working on that or combination activities within that time period. Alright so far? But let's suppose that we only had 4 people available to us. Well, just looking at this, we can see that this period here is going to give us a problem. Here apparently we need 6 people for week 17, 18 and 19. There are 2 things to consider here. It might be that since we haven't got these people, then the tasks within this period need to be adjusted so we don't need any more than 4 individuals. Another general rule is that keeping the amount of resources fairly level throughout the life of a project is good management practice. For example, in these weeks, managing 6 people is more complex than managing 4, even if you had them. So it's good practice to try and keep this as level as possible, but also take into consideration, do you actually have the resources? Because if you don't have them available, this so far is still an unrealistic plan. And this introduces nicely the concepts of smoothing and leveling, which you'll need to understand for Microsoft Project. The first step is called resource smoothing or time-limited scheduling. And resource smoothing is used where you in effect have unlimited resources, but you have a fixed end date. So resource smoothing is adjusting the schedule using your unlimited resources, moving activities within their free and total slack. I've only talked about slack so far. Live with me for the moment on this. We'll discuss this in a later module. So moving each task within its slack period in order to achieve a smooth and manageable resource profile across the project, but without moving the end date. So when management say we must have this by the 5th of December this year, for example, then what you'd want to do is to smooth the contour of resources across your project. You want to try that first to get a smooth and manageable project with resources assigned as needed to ensure that you can meet your end date. But what happens if you don't have unlimited resources? In other words, real world. Well, then the only other option is to do what is called resource leveling. And what this means is that when you do have fixed or limited resources, this is called resource limited scheduling for obvious reasons, then we move activities within their free and total slack if that is possible. However, if it's not, we may need to move tasks out in time so that when resources are available, and therefore achieve an end date which is realistic within the limitation of the resources available. Now this is important you understand both these concepts. Often management will say, no, we need this end date, but we do have limited resources. Well, that isn't always possible. What you're doing for management here is finding a realistic end date given limited resources. If they don't like that, then you would say, all right, if to keep this end date, here's the amount of resources we actually need to make this an achievable plan. So be aware of these 2 terms, and we'll be using those in later modules. Now I want to touch on the aspect of project control, because Microsoft Project is there to produce a realistic plan, get it approved, and then start to deliver against that plan. And it's important you understand the mechanism, if you will, of how the project is managed, monitored and controlled. We have to start somewhere, of course, and let's imagine the project manager has given out work. Then there's an important activity called review work status, capturing what has actually happened versus what has planned. And the way in which you'd capture what has actually happened is by work reports in some way. Whether it's a verbal questioning of the team and finding out what's happened, how much work has occurred, what tasks have been finished, what tasks are still in progress, and so on and so forth. So we would use completed work along with work reports to see what has been done and what has yet to be done. And the yet to be done, of course, is called forecasting, where we've actually done some, but we've still got some remaining work to do. And I've called this review the project status. But here's the point. All of we're doing here is capturing actuals, comparing it to the project plan, inputting that actual information into Microsoft Project, and then as a result of that, seeing what the forecast is and updating the project plan to show the latest forecast. And this is where the project manager will need to undertake several activities. To give progress reports to appropriate people as part of communication, notably to senior management, to authorise new work once certain work has been completed. This of course will be an ongoing thing throughout the project, and giving that normally in the form of work packages. Whenever work does not proceed to plan, here we're seeing what we planned, here's what's actually happening, here's what the forecast looks like. If we don't like what we see, we need to take some form of corrective action. It might be to catch up on lost time, to get extra resources, to work overtime, or to modify future tasks, or to agree to rescope the project in some way. This is generally called take corrective action. And of course it would manifest itself in terms of the project manager authorising new or modified work to bring the project back on track. You may be taking corrective action as a result of a request to change in some way. Perhaps functionality now needs to be different. And to do that, we'd also need to consider something I've touched on already, which is issues and risks. These are normally held in things called risk or issue registers or logs. They might be a simple document set, or it might be a spreadsheet or a database. And this is used to help the project manager manage such issues and risks. And it's as a consequence of these arising that the project manager may need to take some form of corrective action. But the way in which we know whether that's necessary is because these issues and risks are part of reviewing the project status, and on the basis of that, seeing what the new future looks like, and if necessary, take such corrective action. The final piece, of course, I suppose, is that having looked at issues and risks and the situation as thus far, when you see that what you're forecasting would not be acceptable and it needs to be escalated up to management in some way, often in the form of what's called an exception report. So the other activity of a project manager is not just managing, monitoring, controlling, but as part of controlling, where necessary, escalating this as and when appropriate. So what I've given you here is a little simple model of the daily life, if you will, of a project manager. And I hope you can see here that Microsoft Project is not only used in the first place to create a realistic and achievable project plan that is now approved, but in the second place, Microsoft Project is used to help manage, monitor and control such plans. Finally then, applying project management, taking the need, problem or an opportunity, where project management is the process by which projects are defined, planned, monitored, controlled and delivered so that agreed benefits are realised. Also summarising here, what we'll need is a business case showing that the project is and remains viable, that we understand what the success criteria and what the benefits are of carrying out the project, manifesting this in terms of understanding the scope, time, cost and quality, and producing a realistic and achievable plan. Making sure that you have the right resources and that they've been approved and agreed and such that they're assigned to carry out the work against this authorised plan. The work is now given out by the project manager, and the project manager will monitor, manage and control such work activities, ultimately resulting in the project delivering products which will realise benefits. If this brief overview in this first module has held some interest for you, you might like to check out my PMP exam primer, which you'll find at www.pm-primer.com. However, thank you for your attention for this first module. Let's now move on to module 2, where we'll look at the use and application of Microsoft Project.